Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at the use of text on a graphics window. Today we're going to be looking at putting text onto a graphics window. I've done some preparatory work to prepare our program. This application will run either in the Windows console or Windows compilers. We've achieved this by putting a few lines of code into the program. We're testing for this constant, which if this is present, we're turning the console off. So if you're running the console compiler, a console will not display on the screen. We're purely going to be using this program to display a graphics window. We're also using one of the include libraries for our file handling routines because we're going to be reading from a file. In the pbmain function, we're setting up the graphics window to be a particular size on screen. We're then marking the window as stabilized, which prevents the user from closing the graphics window, which would not actually end the application. We're then attaching the graphics window so we can stream to it, and we're setting up a courier, which we're going to be using to display the text on the graphics window. We're then clearing the screen and setting the background to be black. When we created the graphics window, we're using the redraw option, which means whatever messages we send to our graphics window will not be displayed to the user until we perform a specific redraw command, which we are doing down here, graphic redraw. And at the very end, to allow the user to cleanly exit the application, we're waiting for a key to be pressed on the keyboard. When any key is pressed, the graphics window will close and the application will end. So if we run our application now, we will get our plain graphics window appearing on the screen with a note on the dialog itself to press any key to exit. When any key in the keyboard is pressed, the graphics window will close and the application will end. I've also created a small text file, narration.txt. This is a file we're going to read and put the text contained within it into our graphics window. As you will see from this text file, there are a number of lines of text within it. These lines of text are quite long, and in fact, paragraphs. The first thing we will do is to create a local variable. This variable is going to be used to hold the text that comes in from the file. And then we'll use one of the routines in our file handling library to load the text into that variable. The binary file as string function. So now that we have the text loaded into that variable, how can we display this on the screen? Well, first of all, we'll set the colour of the text we want to appear on the screen by simply using the graphics color command to have the foreground of the text in green and the background as black. And then using a straightforward graphics print command, we can take the data that's in that text variable and display it on the graphics window. So if we run that application now, so we will see that the text has been added to the graphics window, however it's in one single line, and it runs off the edge of the page. Now the font we're using is Courier New. Now that's a fixed width font, so it should be possible using this font to work out how many characters can display on the screen, and to fold the text so that it would fit. However, while that would work fine when we actually knew beforehand what text was going to appear on the screen, there is always a possibility that the user will have a facility to increase the size of our font. Since the font we're using is Courier New, this is a fixed width font. Each character is exactly the same width. And since we know the point size, we can quite easily determine how many characters would be able to fit on one line, on the assumption that we knew the text that was going to be displayed. However, in some of your applications, the text will not be known to you beforehand. This may come from a user, this may come from an external system, and you may also have the need to handle proportional fonts. So how can we actually take this text and display it on the screen to allow the user to see it? Well, the first thing we can do quite simply is to realize that the text we saw in the file had a number of carriage return line feeds in it. So we can parse the data that's coming in that variable using our parse command. So a simple for next loop looping around the str text variable looking for carriage return line feeds. So if we try running that now, so we have a slight improvement. We've now picked up each paragraph. However, the data for each paragraph is still running off the right hand side of the window. We need a way of folding this round so we can see all the text. So before we send the text to the graphics window, we're going to use a command called graphic set wrap, and we're going to set that to true. If we run that now, we'll see that the text is actually wrapping round quite happily, but it's splitting in the middle of the word. So we're getting closer to wrapping our text. So the command we need to use instead is the graphic set word wrap, and marking that as true. If we run that now, we'll see that quite happily our text is now folding round at the end of words, and we have all the text on the screen. So we have now achieved taking the text in our file and displaying it on a graphics window. However, what happens when we change the font? Perhaps making the font slightly larger. Let's change our font to 32 point. Well, it's still folding round quite happily, but we're losing some of the text at the bottom of the screen. The screen is now no longer large enough to hold all the text. How can we handle that? In order to achieve this, we need to use a virtual graphics window. So before we send the text to the screen, we're going to use graphics set virtual, and we're setting this to be the same width as the window was originally, but to be double the height. If we run that now, we'll see that we now have an automatic scroll bar, which if we scroll down, we'll see we can go all the way down to the very last part of the text. However, putting the scroll bar in is actually losing a few pixels off the right hand side. We don't have any margins set up to make this look a little more presentable. So the next thing we'll want to do is to change the graphics window to allow the setting up of margins. So we're going to create 4 local variables for the left margin, the top margin, the right hand margin and the bottom margin. And we're going to give them values. We're going to set 40 pixels for the left, right and top margins, and we'll leave the bottom margin as 0. So in order to apply these, we need to use the graphics set clip command. It takes 4 parameters, which are the sizes of our 4 margins. Since you could be setting a number of graphics commands to a window to put either images or text on a window, it's always good to set the position before you begin. So the position coordinates always start from the top left hand corner of the graphics window. So when we run the application now, we'll see that we do indeed now have both left, right and top margin set, which makes the text on the screen more presentable and easily readable. And our scroll bar allows us to scroll up and down. So now that we have our raw text presented on our graphics window, can we place a title at the top of the text? In order to do that, I'm going to move the graphics set font command down to just before we actually display the text, because we're going to set the title in a different font. So we're going to set up some local variables. We'll set up a variable to hold the text, which will be the title. We're going to set up a handle for the title's font, and we're going to set a point size for the font itself. We're going to make our point size for our font 42, and we'll add some text to our title variable, and we will prepare a new font. We're going for Times New Roman. Now Times New Roman is a proportional font. We're setting the point size, which we'd set at 42, and we're going to be setting this one as being bold. And using the graphics set font command, we'll set the font we're going to be using for any text being sent to the screen. So if we just print this title to the screen, let's see what it looks like. Our text has appeared on the screen and it has folded round. However, what if we want this text to appear on a single line and not fold round? The font we have picked is obviously too large. We could attempt to lower the size of the font, which would work since we know what the text is going to be. However, in some circumstances we may not know beforehand the number of characters or the content of the title. How can we automatically set that title to fit on the screen in a single line. Is there a way to determine in code if the title font is too big to fit? So the first thing to do is to work out the size of the canvas, minus the size of the margins we've set up. This gives us the drawing area on the graphics control. We can use the graphic getCanvas command to populate the long width and the long height variables. At the moment we're not interested in the height, we're just interested in the width of the graphics window. So the operational width we can use is equal to the width minus the left and the right margins. Once we've got that far, we need to work out if the text will actually fit. Since the font we're using for the title is a proportional font, we know that it's not just on the number of characters. Thankfully, PowerBasic does give you a graphics split word command, which we can use quite happily to work out if the text will fit. So we're going to create two local variables, one called first part and one called second part. The graphics split word command takes two key variables, the title which we want to actually print on the graphics window, the width which we have just calculated, and it will send information to these two new variables, first part and second part. If the second part variable has data in it, it means this is the overflow, the text that will not fit on a single line. What we will do now is a while loop, and within this loop we will reduce the point size and try again until the text actually fits. We will decrement the value in the point size variable. So initially this was set at 42. So if the text does not initially fit, we will reduce it to 41 and we will retest. So we need to end the font and create our new font with the new point size. So we've now created a new font with the new point size, and we've set that font to be the font used on the graphics window. We can then use the graphics split word command again to work out if there's any overflow into the second part variable. If there is, this loop will go again and decrement the point size. And this loop will continue until the second part variable is no longer populated. At that point, we will know that the text will actually fit on the graphics window for the point size we've set. So if we try running that now, the text now appears on one line for the title. So we have reduced the point size to a point where it will fit. So what we've achieved today is we have taken a graphics window and we have populated that with some text from a text file. We have folded the text round on a word boundary so that words do not get cut off at the right and left hand side. We've set margins on the graphics window to allow the text to appear quite cleanly and not be obscured by the scroll bar. We've set the graphics window to be a virtual window so that the user can quite happily scroll up and down and see all the text. The last thing you may wish to do on this graphics window is to allow the user to be able to resize it. Users are quite used to resizing windows. This one at the moment has no resize gadget. This can be quite easily done when we set the virtual window size. There is an optional parameter called user size. When that optional parameter is in place, when we run the code now, you will see there is a resize gadget at the bottom right hand corner of the window, which will allow the user to resize the window. Graphics windows are a very useful way for displaying information to a user. And running the application this way allows you to have code that will run in either the PowerBasic console or Windows compilers. The same type of commands can be used in graphics controls on dialogues. However, that's it for today. Thank you for watching.